Lately I'm working on Phytist, which is an abstraction layer in Amethyst, and an idea that I had for this video is to talk about the abstraction layer for the physics. After the publication of Phytist proposal in the Amethyst forum, I thought that it's not so interesting to talk about the abstraction layer applied in the physics engine, and the idea of this video is to talk about the abstraction layer in general. And as first thing, let's talk about the benefits that we have using an abstraction layer. And the first thing, of course, is obtained thanks to the fact that the controller is built on around the behavior that you expect from a specific module rather than a mechanism. Later, when you want to change the mechanism, or you want to support more architecture, it's much more easier replace the module. But of course there is a downside with an abstraction layer, because it requires more effort during the implementation. Because when you implement something that uses an abstraction layer, you before have to design the abstraction layer, because it's not enough design the abstraction layer around the mechanism. Otherwise you are constraining that abstraction layer on a specific mechanism. Rather, you want to design the abstraction layer on a behavior, so you have to do more steps in order to implement first the abstraction layer and then the actual implementation. Due to these two characteristics, it's not always convenient to implement an abstraction layer. And my personal way to choose if I have to implement or to not implement the abstraction layer is based on this reasoning. What I usually do is to watch the feature that I am implementing from the perspective of the application, and if this feature is the main feature of the application, or if a secondary or a side feature of this application. Let's do an example. We can consider a game engine where to provide physics capabilities or rendering capabilities or audio capabilities is a secondary feature for a game engine, while the primary or the main feature of a game engine is to orchestrate all these engines together, the physics engine with the rendering, with the audio, etc. By implementing an abstraction layer for these secondary features, what happens is that you are enriching, improving the main feature of a game engine, which is again the orchestration, because orchestrate at the same time more physics engine or more rendering engine or more audio engine at the same time is much more better rather than orchestrate just one physics engine. To do the opposite example, instead we can say that the orchestration is done thanks to the dispatching mechanism, and create a dispatching abstraction layer. What means is that you are stoning the behavior of the dispatching capabilities. This means that later, when you want to improve the dispatching, you have to also change the abstraction layer, so you have zero benefit of creating this abstraction layer. So to make it simple, in order to choose if use or not use an abstraction layer, I watch the feature from the perspective of the application, and if this feature is secondary, it's likely that implement an abstraction layer is much better. Let me know in the comment below if you like this way, or if you dislike it. I will be happy to answer your comment if I have time, but if not, I will for sure read it. Thank you again. See you. Bye.